So yes. Can you see the screen now?
Yeah.
Yes. So I'll just open the file that I'm making. So actually what is happening is like, so I'm working with L-glutamic acid. So what I wanted to do is like, I want to study the interactions between L-glutamic acid and water. Typically, I'm working on crystallization and polymorphism. So I'm trying to adjust some process parameters in the operation to get better yield or else pure alpha polymer. So I'm doing experiments parallelly. So I want to understand the interaction between the solvent and the glutamic acid by doing some molecular dynamics simulations. And while coming to this, I've taken some course on this MD simulations as well, where they use Gromax lamps and these kind of things. But since we have this facility of Material Studio, my professor
Mhm.
wants me to use this. But here, what is the case is like here there is no one who is aware of this software, who is currently using it. Or there are PhD students who used it earlier. Now they are not there on campus. So basically, I'm facing some issues while using it. So what are the issues is like, first I'm doing a geometry optimization. First time I got the CIF file from CCDC website of glutamic acid,
Mhm.
and I've uploaded into this my Material Studio. Along with that, I'm uploading water molecule as well. I did geometry optimization, and then using this amorphous cells module, I'm loading them into a PPC. So
Mhm.
till that it is fine. So after that again I did geometry optimization, and then I when I try to run the simulations for 50 picoseconds or 100 picoseconds, the molecules are coming out of the box. I'll show you that like how it is happening.
Yeah. Also, let me understand. I'm
Yes,
gonna ask questions because that is how I get the idea of what's going on actually. So,
yes, please.
you're accessing some other PC which has Materials
Yes,
Studio, via
yes,
any disk, right?
yes, yes, yes,
Okay, cool. For now, that's good enough. Let's go. And
yes,
IIT Gandhinagar, does it have SPC like its own cluster system
yes, yes.
or?
HPCs are there.
Hmm.
I have seen your YouTube video like how to submit job files on HPC for materials. I haven't tried. I want to try that. I used
Yeah, yeah.
HPC for running simulations when I took the course on MD. So
Hmm.
we used to use it for Romax, and recently I've taken one more course on that. We used to run this SAM GUI files as well. OpenMM based SAM files to run the simulations.
Okay, let's do this. Let's open this Materials Studio project.
Yes. So this is the material. So here I've taken this L-glutamic acid.
Hmm.
After taking this L-glutamic acid, first I did L-glutamic acid geometry optimization, and then I did water geometry optimization as well. Then
Uh-huh.
I tried both packing as well as construction.
Hmm.
So first, if I go through this construction, so this is the molecule. This is the PVC.
Right.
So here I packed one L-glutamic acid and 1400 water molecules.
Oh, there is acid in it. Can you show like where it is? It's quite small. I can't see probably. Ah, I see, I see. Yeah, it's quite small.
Yes, yes,
So,
yes.
okay, makes sense. Cool, cool.
So after this, I tried first NVT
Mm-hmm.
and mix. So I did for this thing. This is for 10 picoseconds. We confirm
Uh-huh.
it. Yes, this for 10 picoseconds. I ran.
Mhm.
So then I again submitted the same for more time. So yes, this is happening.
Yeah.
To last, yeah, this is the case. Everything
Yeah.
came out of this PPC box.
Mm-hmm.
So this
Okay.
is the case with construction.
Uh-huh.
If I tried packing as well.
Mm-hmm.
So in this packing, here is also the same case. If I submit it for more time, it's already started coming out of this PPC box.
Okay.
So this is the problem I'm facing. I don't like. I tried by changing different parameters while submitting this job.
Uh-huh.
Like in the module, if I go into this foresight, there are different things I changed and like a trial and error I tried. First of all, I'm very new to this simulations and these things. So and that's the main problem. So I think because of this and lack of understanding on this system, so I might facing these issues. I tried with different force fields and I changed everything mostly, but yeah, somewhere I'm getting the error.
Okay. So I'm gonna take control. Allow me.
Okay.
I have control, I think now.
Yes.
Open the other application, Materials Studio application. Yeah,
Uh,
that's good. That's all. That's all.
module.
No, that's it. That's it. Okay, I'm gonna just
Okay.
it's gonna be slightly slower.
Okay.
All right, and let's close this one and go to view. Um, Toolbars and an animation because I don't see the animation tools here. Can we like
Oh,
make it bigger? This task?
um, I think here that's a problem.
Well, in that case, leave it. I'll figure out something else. Okay, this is better. Uh, Better, much better. Right, I'm gonna because we cannot see the animation toolbar, so I'm just gonna drag it somewhere here. Um, Okay, so we'll have some more space for animation toolbar to appear.
Okay.
Okay, it's here now. And by the way,
Yeah.
um, the first thing that I notice is what is end-to-end distance of this molecule, this acid?
Uh, that there is like VW van der Waals distance that you're asking while placing it.
No, wait. I'll figure out. So this is your geometry optimized structure.
Yes.
Uh, there should be a distance monitor here.
Okay.
I want to measure distance between this atom and say this atom.
Oh,
So that's about 7.354 angstrom, right?
yes. Yes.
And that's not too bad. And the molecule that we had, the box size is um the dimensions we can figure out from probably display options, I guess. Oh, lattice parameters.
Yes. Yes.
So 3.43 nanometers. So the first advice I think would be to have slightly, less number of water molecules because it's just too big box for
Okay.
um, glutamic acid because it's just 7 angstrom, 8 angstrom, right? So
Okay. Yes.
7 angstrom, and if you leave, say, about 1.2 and 1.2. About 2.5 to 3 should be okay, I think.
Oh, okay. The box size.
Yeah, box size. I mean, if I place it in the center and leave, or even, I mean, you can take about 1.5 nanometers extra length.
Oh, okay.
So 1.5 plus 7 or 8 angstrom, whatever that is, right? That should be good
Hmm.
enough usually. It's just unnecessary computation. And
Okay.
also the behavior that you think is unwanted is not really unwanted. It's very natural behavior, let's say.
Okay.
So here you say that the molecules are skipping out a box, right?
Yes, yes. It
That's
can be seen clearly in that construction in the last bit. Yes,
so
here itself. Yes, yes. Please
this
go ahead.
is the dynamics that you have run after geometry
Yes,
optimization, and this is NVT dynamics. And the
yes.
water molecules are escaping the box, and you think that is
Hmm.
unwanted. No, it's not unwanted. It's perfectly natural. It's just the way the trajectory file is being represented here. The way you're visualizing is different. Let me show you what
Okay.
I'm trying to say here. We go to
Okay.
options in the animation. If we say
Mm-hmm.
recalculate atom visibility every frame, and now you can see that, all right, we need to change one more thing, I think. Display style. And the way lattice is being represented,
Okay.
we'll call it incel and just play the trajectory. You see the difference? The
Yes,
problem is
yes.
not with the simulation. The problem is the way it is being represented. It's not even the problem, actually. It's just how you want to see it. So, um, molecules are still in the box. You don't have to worry about it. Since you're simulating PVC in all dimensions,
Mm-hmm.
and the way you are representing
Mm.
causes molecules to escape out of the simulation box, but it's not really, I mean, that is what is happening if you see in a bulk when you implement
Okay.
PVC, all right? So
Okay.
that kind of representation is
Mm-hmm.
called unwrapped trajectory. Unwrapped meaning if a
Okay.
molecule leaves the box, let it
Mm.
leave the box. Do not represent it as if it has entered from the other side.
Okay.
But in the calculations, when the trajectory is evolving, the MD engine
Mm.
solves everything, including PVC. It takes care of that. But when you're
Okay. Okay.
representing, that's when
Uh-huh.
it just leaves it going outside instead of, placing it back from the other side, inside the box. So
Sorry,
that kind
like,
of,
uh,
go ahead.
sorry to interrupt you. Uh, actually, I didn't got like what is happening. What's the main problem in this? Can you
No,
repeat it again?
yeah, there is no problem.
Okay.
So molecular foresight module is an MD
Mm.
engine, right? It solves those equations, classical Newtonian equations, so that your
Okay.
trajectory evolves over time. All
Okay.
right. It takes
Mm.
care of PVC. So when it is
Okay.
solving the this trajectory basically over time,
Mm-hmm.
it takes
Mm-hmm.
care of PBC, the MD engine. But
Okay.
when it is being visualized on the interface,
Oh.
when on the G in the GUI, you
Ah,
can
understood.
choose to see atoms as if they are in the box, or you can also choose to see atoms if they were leaving the box or not.
Was. Okay. Okay.
You can see
Understood.
in both ways, okay?
Yeah,
So
okay.
right now, the settings make sure that the
Mm-hmm.
bulk system is being visualized.
Okay. Okay.
The the way you were visualizing before is
Mm.
useful when we want to calculate chain dimensions, for instance, all right? Say I have a
Mm-hmm.
molecule which is at the interface, say at some boundary,
Okay.
maybe in this boundary, say somewhere here, this surface OBC, this is
Mm.
the surface,
Mm-hmm.
right?
Yes.
Say your chain is somewhere here, a part of
Mm.
chain is outside of the box and a part is inside the box. All
Okay.
right.
Okay. Okay.
Because of the periodic boundary conditions, The other part, which is outside of the box, will go and appear from that other
Inside.
boundary, right?
Yes. Yes. Yes.
Now, if you
Understood.
want to calculate end-to-end distance of that chain,
Hmm.
one atom will be somewhere here because it's
Hmm.
inside from this surface. The other atom will be somewhere on the other side because of the
Yes.
PBC implemented. And if you
Yes. Yes.
calculate the bond distance, sorry, the distance between those two atoms, it will be wrong.
Okay. Ah,
It
understood.
will be
Yes.
too much. So what you want is you want a whole molecule to be represented where it is, as it is.
Okay. Yes. Okay.
So what you want is in that case, you don't want in-cell representation. Rather, you want the
Hmm.
original, where all atoms are just, as they were, as they would be
Okay.
simulated in a bulk system.
Okay. Yes. Yes. Yes.
So
Understood.
you want the polymer to be right here, even if
Hmm.
outside some part is outside. You leave it as it is, okay? And then you calculate
Okay.
end-to-end distance.
Okay. Okay. Okay.
So
Clear.
that
Yes.
is called unwrapped trajectory. It's not wrapped in the box, it's unwrapped.
Okay. Okay.
So the behavior is perfectly natural. Now you know what is wrapped trajectory and unwrapped trajectory when you can use
Yes. Yes.
unwrapped trajectory.
Yes. Understood. Yes.
Another suggestion is you don't have to use this big box. Right now, you're since experimenting, it's all fine. But when you're gonna
Hmm.
go and do some deep research, this
Hmm.
will l- this will kill a lot of your time, seriously. So make sure you know what dimension a box will do the job.
Can I ask you one thing? Like here
Mhm.
in this material studio, uh, we cannot decide the box dimensions. I think, as of my knowledge, I don't know like whether we can decide box dimension or not. After giving the number of molecules that we want inside the box, it itself defining according to the number of molecules the box is, what the box is required is. So why I have taken 1400 water molecules and one glutamic acid is because I'm doing experiment in such a way that 1:2 ratio of L-glutamic acid and the anti-solvent or the solvent. So based on that, I've calculated number of molecules of L-glutamic acid for L1 L-glutamic acid. How many molecules of water are there? So based on that calculation, I've added one water molecule needs 1400 of one L-glutamic acid needs 1400 water molecules according to the experimental calculations. That's why I added it. I like, is it needed to do be like that, or we can add less number of water molecules? Will that work?
I think I can help you there. So,
Okay.
if you know the weight percentage of glutamic acid in water molecule,
Hmm.
you can construct that. Let me show you. So this is your one, another. First of all, let me close all
Okay.
these windows. We don't
And one
have to
more thing I
save.
want to ask you.
Mhm.
Okay, I'll ask afterwards. Okay, then. That's no problem.
So right now, whatever changes is I have made, like here, you see the
Mm-hmm.
lattice, the weight is represented. I changed it to
Mm-hmm.
incel from original, right?
Inside.
Also, I
Oh,
said
yes.
recalculate atom visibility every frame. So these things I'm
Yes.
not saving. You can do it later,
Okay.
just to
Okay.
visualize, right?
Okay. Okay. No
Um,
problem.
for now, I'm gonna close these windows.
Mm-hmm.
We're gonna go to construction, um, amorphous cell construction here.
Mm-hmm.
So glutamic and water.
Yes.
Say your glutamic acid concentration in weight percentage is 1.15, okay?
Yes. Yes.
You know that. So according to that, I mean, you know the concentration, according to concentration, you chose this many water molecules and you just created a box, okay?
Yes. Yes.
Okay, so I think you're doing good. If you know the concentration there, you're doing good. You're doing good. So here it's all good. You have constructed
Okay.
the correct box.
Mm.
So once you construct the correct box, also let me check that's geometry optimization. Look at this, the density that you are putting. So basically, you
Mm.
want the system that has density of 0.8 gram per centimeter cube, right?
Yes.
Water molecule
Actually,
density,
I followed your video that it's better to give less density Like I water density is 1 gram per centimeter cube. So you said in that if you give less density, it evolves to the required density on running the simulations.
Yeah. So that's what I was going to suggest you actually.
Okay. Oh, okay. Okay.
Um, Usually when you are creating a box, constructing
Hmm.
box,
Hmm.
you want to give initial density to be low, which
Okay.
means big volume, right? It
Hmm.
is way much easier to pack 1,000 molecules in a larger volume compared to a smaller volume. If you want to
Okay.
pack same number of molecules in a smaller volume, it will
Hmm.
take more and more time,
Okay. Okay.
and it may not even be able to do that actually. It may just fail in packing.
Okay.
So this is usually what I do. I know water molecule at that temperature and pressure will have say 1,000 density kilogram per meter cube, okay? So I
Hmm.
will go for zero point 0.5 gram per centimeter cube or zero point 0.3,
Oh, okay.
okay? Very low,
Hmm.
so that the box is very big. Atoms
Okay.
can be packed pretty quickly,
Okay.
and I will have my constructed box. Once I have that constructed box, I can run like 50 picoseconds to 100 picoseconds of NPT ensemble dynamics. That
Okay.
will
Okay.
allow my system to shrink in size.
Oh,
And the
yes.
water molecules will naturally adjust to the density, which is correct density at given temperature and pressure. So
Okay. Okay.
just 50
Understood.
picoseconds to 100 picoseconds usually gives, I mean, depending upon the system size also, but usually for the system sizes that I have worked with, that is good enough. And that takes me, from larger volume to smaller volume, or say a
Mm-hmm.
smaller density to good density, the density that is actually correct. Okay. So once I have
Okay.
that,
Understood.
after 50 picoseconds of NPT ensemble, once I have that correct density, I can run it
Mm-hmm.
through NVT ensemble for like 50 picoseconds again, just to make sure that it
Okay.
is equilibrated well enough.
Mm-hmm.
And then I can go and do, if I want NVT ensemble production run, I can do that, a nanosecond
Okay.
or two or 10 or 100. Or NV, if I
Okay.
want to
Okay.
run that also I can do. So make sense like what should be the protocol from
Mm-hmm.
constructing to going to production run.
Okay. Okay. Yeah.
So right now,
Yes.
what you did is you constructed the box at zero
Mm.
point 0.8 gram per centimeter cube, and you did NVT ensemble. So the simulation that you have
Mm.
done is not really realistic. It is still in equilibration phase. You need to run through
Okay.
NPT ensemble just to ensure that the
Mm.
density goes to the correct value. Run it
Okay.
through
Okay.
100 nanoseconds and
Mm.
keep looking at the density plot. When you see that
Okay.
it has, become, you have reached the plateau, after
Mm.
reaching like 30 seconds of plateau, 30 picoseconds of plateau in density
Mm.
plot, you can stop
Okay.
the simulation and then run it through
Okay.
NVT. That should
Okay.
be your
Nice.
production run.
Okay. Fine. Yeah. Understood. And one more thing is that actually, if I have a CIF file with me, uh, suppose in glutamic acid there are two polymers. One is alpha and one more is beta. Actually, I had CIF files on my laptop. So when I'm trying to upload the CIF files into Material Studio, it is uploading as it is like that. Along with glutamic acid, there are some other molecules as well. I think they are water molecules. So how to remove the water molecules which are in excess, or else is it okay to simulate that CIF file directly?
I'm sorry, come back again. Say that
Yeah.
again, the question.
Yes. Actually, in glutamic acid, there are two polymers. One is alpha and one more is beta. So
Mhm,
I want to simulate alpha as well as beta. So when I'm trying to upload the CIF files into Material Studio, it is uploading in such a way that along with L-glutamic acid, there are some other water molecules as well in that lattice structure.
mhm.
So how to, is it okay to run the simulations with the same CIF file, or else I need to clean the water molecule, or else do I need to do something to remove that water molecules which are in excess other than L-glutamic acid structure? I think it will be clear if I can upload that CIF file now.
Okay, so you have a CIF file which has glutamic acid and water molecules in it, right?
Yes, yes.
And
If possible, can you go here to upload that molecule? I'll show you the
go
location
ahead,
of it.
do it. You also
I
have the
think
control.
no, this I think it's in your control. I can see the pointer.
Oh, okay. So I'm
Okay.
gonna go to files
Yes, yes, yes.
and then import probably.
Yes, yes.
Before that, let me choose the correct directory.
Okay. And let's come to this Venkatesh and compounds. Yeah, these are two CAF files, alpha glutamic acid and yes.
So I'm gonna open this one, right?
Okay. Yeah, it looks like this.
Better. What? It's just two-dimensional or what? I cannot seem to.
I think here on the yes, yes. Uh,
Interestingly, all right. Let me look at the file. Mm, Where is Venkatesh, by the way?
yes,
Here,
yes, yeah, yes,
compounds. And this is what we opened.
yes, yes.
It does have XYZ, all the data. That means it has to be three-dimensional. How come? And I can't rotate it. Anyways,
Oh,
so yeah,
it will
interestingly.
happen. I think you can try maximizing the screen of that. Oh,
This won't work. Something has to be weird with this structure. Anyways, so yeah, it's better. Tell me, what do you want to do next?
so in this, I can't see like if I try to give the bonds in it. Uh, there is an option right on the top in the menu bar to form the bonds in between these molecules.
Like you can create bonds, right?
Yes, yes.
All right. So, um,
Here,
let me
don't tell
understand what
me.
exactly you want. You want glutamic acid in your Materials Studio, right?
Yes, yes,
So, have you checked with his structures? There is a structures directory in Materials Studio
yes.
where Materials Studio provides you with so many structures actually, polymers, metals, so many clusters, all those things. Uh, have you checked whether glutamic acid is available in that repository or not?
No, no. I
It's
haven't
not
checked in
available?
that. Actually, I'm
Like,
trying to upload from the CCBC website only.
okay, so the problem, like, we can import those files, it can read XYZ data, but
Mm,
Materials Studio's native format, which is XSD structure format,
mm, mm,
has a lot of other information which CIF file does not have. For instance, which
okay.
atom is bonded to which one? What is the name of
Mm,
atom? It might differ between the two file formats, right? So when you import it,
okay.
what it really imports is XYZ. and probably also the
Okay.
element names. The other things are missing
Okay.
still. So either they should be created or
Hmm.
they should be, you can go and write also in the file actually, but it's just too much of work. So it's
Hmm.
always better to just create that molecule right here. And from what I
Okay.
have seen, the glutamic acid is not that big of a deal to make in Materials Studio itself. So you can just,
Okay.
maybe I can show you.
Hmm.
So we want alpha glutamic, right?
Yes.
The spelling is correct.
Yes. Alpha glutamate. Yes.
All right. So also, I'm gonna have to open alpha glutamics. This one is alpha glutamic or what?
This is actually what is the case in this is like already L-glutamic acid studies has been done by my senior
Hmm.
PhD student or master student. So I'm using that XSD file which they had. So I try to connect with them. I think it is beta. When I'm trying to upload the CIF file of alpha or beta, which I got from CCDC, I'm getting this error, or else I'm unable to understand what is happening in it.
Uh-huh. Interesting. So here what I'm trying to help you do is since you want
Yes,
glutamic acid native structure format in Materials Studio, we want to just get that here. Okay. And how we can do
yes.
that? Uh, I was trying to create or sketch the structure in Materials Studio right here.
Okay.
And in order to do that, I need to see the structure. And that is what I was asking. Is that structure, alpha glutamic, the same with this one? Is this the structure?
Okay, I understood your
Is this the
question,
structure we
but
want to create?
yes, this is the structure.
So when this glutamic acid is already available
Hmm.
in native structure format in Materials Studio, why do you want to import it through CIF file?
Yes, that is because I'm not sure this L-glutamic acid is whether alpha or beta. I'm using this file
Oh,
because previous simulations were done using this L-glutamic acid. Actually, I've recently started using this Material Studio software, so that's why I'm not sure what is happening with this. So I downloaded alpha and beta, but I'm getting that problem.
okay. So
Yes,
here is the problem. You're saying that you're not sure if it's alpha or beta glutamic acid, right?
yes, yes.
I would suggest to find out the structure of alpha and beta glutamic acid from the
Mm,
resources, literature, or internet, okay?
mm, mm,
And be sure of that first. If this is alpha, you don't have to import the CIF file because
mm.
I'm telling you, like when you import, those formats, they have some missing things in their text
Okay.
files, okay? And
Mm,
importing is usually XYZ data. That is what you're importing basically. And
okay.
this structure is not that complicated to make a sketch in Materials Studio. Materials Studio Sketcher is really good. You can make some
Okay.
certain like really good complex molecules. There are all the tools available here. So what I would suggest is just look at the alpha glutamic acid and beta glutamic acid structure and it has to be one of them.
Mm,
I'm not I do not know about these structures, but if it's one of them, it's all good. You can just copy paste it there. If it's not, maybe a little bit of change is
okay.
there. You can just make that change right here in this
Mm,
structure, right? And if you do not know how to
okay.
sketch, I can help you with that for sure.
Okay. Okay. So one thing is like if I sketch the molecule on the material studio, how to fix this bond angles, bond lengths, and torsion angles, these things.
So um, those things you do not have to fix. Oh,
Oh,
you mean like you do not want them to vary? Like when you're doing molecular dynamic simulations, bond angle,
no, no, no,
bond
no.
stretching.
They can vary. Yes, yes. The simulations I'm doing is about that, studying the torsion angles, how it is varying in the molecule.
Mhm.
Hmm.
So why
I
do
don't
you
want to
want to
fix
fix
them.
it then? Okay, then what do you want to do with the dihedral and all those things?
So basically, before doing the simulations, it should be in beta state, or else it should be in alpha state when I start the simulations. And then I want to see how it is evolving or how it is transforming from alpha to beta or beta to alpha based on the conditions.
Right.
Yes, so that's why like initial structure I want either alpha or beta. So that's why I'm concerned about this torsion angles or bond
So
length.
that's what I'm saying. You don't have. Okay, fine. So
Yes.
when you know the structure of say alpha or beta glutamic acid, you
Mm-hmm.
can prepare a similar structure. It does not need to have exactly the same dihedral bond angle and all those things. Okay? Bond
Okay. Okay.
distance and all those things. It does not have to be like that. When you're sketching, you
Okay.
don't know a lot of things.
Mhm.
So all you have to do is just drag, I mean, take the molecule atom,
Mhm.
sketch them one by one.
Okay.
Whatever bond distance angle, do not worry about that too much, okay?
Okay. Okay.
Just make a similar approximate structure. Once you have
Okay.
that,
Hmm.
run it through the force field geometry optimization.
Okay.
The
Okay.
force field will take care of it. The whole point of geometry optimization is you have an approximate structure, and the geometry
Hmm.
optimization will put some constraints based on all those
Hmm.
parameters defined in mathematical equations that the structure
Okay.
will most likely go to a state where it is
Hmm.
accurately defined. The
Okay.
bond angles,
Okay.
distances, all those will be fixed by the geometry optimization later. So just make an approximate structure. Do not worry about the angle, distance, and everything else.
Then I will
I
do that.
cannot,
I'll try. I'll try it once with that thing as well.
yeah, do not worry about it,
Uh,
okay? I mean, that's how we do. I mean, I sketch water molecule. I do not
mhm.
import water molecule. There is no need to import water molecule. It's pretty easy, just three atoms, H, H,
Yes.
O,
Yes.
draw the bonds, and then geometry
Yes. Yes.
optimize, length, bond length, angle, everything will be fixed. So,
Yes.
yeah,
And one more
that's
thing is that after doing the simulations, I want to plot RDFs. Basically, I want to study the interaction between this L-glutamic acid and the water molecules. So can you explain me or can you show me like how to plot RDFs or how to do like plotting RDF? I've seen that, but if I want to plot an RDF between a particular set of molecules in L,
you're breaking. I can't hear you again.
okay, okay. Can you hear me now? Is it fine?
Yeah.
Yes. Basically, I want to plot RDFs. I've seen that how to plot RDF between so in the total system basically. If I want to plot an RDF between a particular molecules in L-glutamic acid, suppose the amine, amino group NH3, and the water molecules, like is there any possibility of plotting RDF in like that?
So yeah, let me, we have a trajectory file. Let me load that. What I know, I'll try to show you that.
Okay.
It just opens up and starts playing. It does not stop.
Oh.
Okay. So since you have performed a four-side module in dynamics, let's go to
Mm-hmm.
analysis of four-side module.
Mm-hmm.
And in analysis portion, there should be something with here, radial distribution
Hey.
function, right?
Yes.
So what I'm gonna do is I'm gonna choose a set the water molecules. Why don't we make them ball and stick?
Okay.
Trying to select it, but
Uh, I think there is an option to select these sets in the build module.
build module.
Uh-huh.
No, I mean, even in the trajectory, I should be able to select these molecules. So here's what I want to do. Let me, maybe like I can show you somewhere else if that's edit, and then you go
Mhm.
sets. So these sets are basically you can create multiple sets, okay? Sets
Okay.
are basically group of atoms. So I can
Hmm.
create a set of say just one hydrogen molecule or two hydrogen
Hmm.
molecule or all the molecules, hydrogen molecules in the box, water molecules in the box, I'm sorry.
Okay.
And then I can
Okay.
create another set of glutamic acid. So there will be two sets, one all water
Okay.
molecules, the other one glutamic acid.
Okay. Yeah. Yeah. I want
And
to say plot the same thing. And
right,
glutamic acid and
so
all the water molecules.
that's what we want to do. But I'm just trying to select this and I cannot seem to do that. Maybe this one. It's pretty weird that it's not working. I'm trying to select them. Maybe I'll give you control and you can try doing that.
Yes.
Um,
Okay. Okay. Hmm.
but stop control. All right, you should have control back to you.
Yes, it is with me. So,
So
so basically,
try to double click on any atom in hydrogen molecule, water molecule. Double click.
oh,
It's not selecting.
just a minute.
Mhm.
I think there is a problem. Um, yes,
Yeah.
I was unable to select it.
So um, but that is how set selection works. You know what? Wait. If it's not working right now, I can show you something else.
Okay.
I need control for that.
Okay.
Requesting control.
I didn't got any.
Notifications. You didn't get control. Your request for control wasn't accepted. I'm gonna try again.
Oh, I think it is just a minute. Yes.
So you go to files.
No, it is in that any desk software. Sorry.
Oh, this is yours. Oh, sorry.
Yes. Okay.
So we are supposed to go there. Um, just any files. So this is the index file to open up
Okay.
Materials Studio's manual or documentation.
Hmm.
This will open up in a browser. I prefer
Okay.
Microsoft as I'm going to open up with that. This
Hmm.
is the documentation. This is really interesting tool
Okay.
to learn about most of the things, at least the scripting and everything else. So how do we create
Okay.
sets? I'm going to search something called sets and read about it. Setting up the
Okay,
basis
okay.
set here. Set class maybe. Let me see. This is telling you how you can create sets with Perl, but that is not what I want.
Actually, I tried this, creating sets and doing plotting the RDF.
Uh-huh.
But actually, it is asking some. Do we need to check the intramolecular thing or intermolecular RDF you want?
Right. So for that again, how radial distribution function is being calculated? Here. Read about read this whole thing basically. It will give you what each input means probably. Okay. If
Okay.
not this, then I think there is something called interaction here. Look at this.
Mhm,
What
mhm.
that particular input means is given here. So
Okay.
decide accordingly. So once you have those two sets, select those two sets from
Mm.
where is again Materials Studio. Uh, where is Materials Studio?
On it is. The
Right.
bottom
So
is
this is AnyDisk.
yes.
Okay.
Here,
This one probably. No?
here in the top bottom there is a taskbar in that you can see.
Oh yeah.
Yes.
It's pretty interesting. कंप्यूटर के अंदर के कंप्यूटर के अंदर कंप्यूटर for me. Anyways, so yeah, once you have those two sets, they will appear here. Okay, you can create
Mhm,
from this edit
mhm,
and edit sets. Atom
mhm,
selection usually helps, right? Atom selection
mhm.
based on the element type, and
Okay.
um, there is something called backbone. Here is backbone atom. This will help you select glutamic acid likely because it has backbone, I'm guessing. I can't say that. Anyway, so this will help you select the atom.
Mhm,
Also, you can manually
mhm.
select by clicking on them. See how that
Okay.
works. Create the two sets here, and then choose those two sets here. If you want to
Mhm,
include intermolecular components, what that means you
mhm,
can read in the documentation, and then go for
mhm.
analyzing. Okay, analyze that then.
Okay.
So
Okay.
this will help you a lot actually. If you do not know how it works, go and read documentation, search for the particular, different keywords and read those things. They will help you immensely.
So yes. Uh, these are the things I have doubts like plotting RDF. If possible, can I show you? I tried plotting some RDFs with this system only before unwrapped system like we discussed. So can I show you that RDFs?
Yeah, go ahead.
All this. Okay, let's it's taking time. Yes. So in this, I think no, I think I haven't plotted it.
What do you want to show me, Kavya? I'm gonna get some water. Keep doing it.
Ah,
What do you want
yes,
to show
yes.
me?
Actually, I plotted RDF by selecting this selecting two sets. One is
Okay.
L-glutamic acid and one more is water molecule. I want to
Okay.
show that RDF. So yeah, now I was unable to find it. It's fine. I'll again and I'll write plotting RDFs.
Yeah, try that.
Yes.
Or it does it probably. Do you have any more question?
Yeah. This is the thing I want to ask. And thank you. Like I've been searching for this option since I was unaware that how to do this. And the water molecules are on this molecules are going out of the box and I was clueless. From since I think 20, 30 days I'm doing the same simulations.
It happens. What about your supervisor? Is he not a molecular dynamics expert?
He's an crystallization and polygon experimental work expert, and he's also a person who knows simulation. But yes, he is not that good in this, not aware of this material studio software.
Oh, that sucks. But that's okay. Yeah, you'll figure it out. It takes
Yes.
time.
Mhm.
All right, then. Have a good day.
Uh, I will check it that options you have shown me that in cell simulations after running the simulation, visualization of it doing in cell. Yes, I'll try. Yes, thank you so much
Yeah.
for giving me some
Bye.
time that I can understand.